In this lesson, we're going to be looking specifically at how we now use the unit circle to find those trig exact values. And this particular lesson is going to walk you through the exact kind of problems that you're going to see on the quiz. So in each set, you're going to see 3 problems. And if you think you know how to do them already, I'd really encourage you to pause and get your answers before you listen to my explanation. All right, so let's jump right in. And we're not going to have a unit circle in front of us when we do this, because when you take a test or a quiz or the AP exam, there won't be one sitting right in front of you. So we're going to start off with our very first problem here, which is the cosine of pi over 2. And the key here is just to think, okay, where's pi over 2? Or remember, I start here. Oh yeah, pi over 2 was halfway to pi. I'm right here. Cosine is the x-coordinate, and so that's going to be 0. Now you can be doing this on paper, or you can just be visualizing this in your head, but this is how you would do this. So sine of pi over 6. Okay, so I'm going to draw my quick circle, and it doesn't actually matter how, well, that's pretty bad, but we'll show how even an inaccurate one can be helpful. So pi over 6, remember, here's 0, and here's pi. Pi over 6 is 1/6 of pi. So I pretty quickly see, oh yeah, it's going to be this one. That's 1/6 of this. And I need this point, and I know sine is the y-coordinate. And I always remember, one of these is 1/2, the other is √3 over 2. So I look at my y-coordinate, and I say, am I halfway up, or am I like that √3 over 2 almost all the way up to 1? Which is what, 0.866. And I see, oh yeah, I'm about halfway up. So there we go. And sine of pi over 6 is 1/2. Tangent of pi over 4. I remember pi over 4, that's 1/4 of the way to pi, so that's going to be right here. And this is that one where I just know √2 over 2, √2 over 2. Tan is y over x. Well, if I have the same thing on top and bottom, that just reduces to 1. And we've got our first set done. All right, let's try another 3. If you think you know how to do them, please pause and try them first. All right, here we go. Sine of 5 pi over 6. So I'm saying to myself, 5/6 of the way to pi. Here's pi. I go 5/6 of the way. I end up right here. Sine is my y, and my y goes up. I can see, oh yeah, I'm going halfway up. Y equals 1/2. So this is 1/2. All right, cosine of negative pi over 4. So for negative pi over 4, I am going around this way in the opposite direction, 1/4 of the way to pi, but since it's negative, I'm going in the opposite direction. I recall that this was √2 over 2, √2 over 2. When I reflect over the x-axis, my y-coordinate turns negative, though that really doesn't matter here because cosine is my x-coordinate, so my answer is √2 over 2. All right, let's try the tangent of pi. Oh, we all know where pi is. It's right here. So I say, okay, tangent is y over x. My point is -1, 0. So that's 0 over -1, and 0 divided by anything is 0. So my answer is 0. All right, we have another set of 3. Again, I encourage you to pause this before I work through them, and you can check your answers. So tangent of 4 pi over 3. When I'm thinking 4 pi over 3, it doesn't hurt to think of it as a mixed fraction. So 4/3 is 1 and 1/3, so I've got 1 pi, and another third of the way takes me down here. So 1 and 1/3 pi, and I need both coordinates. So this is one where we're going to reflect up here and up here to pi over 3. Remember, 4 pi over 3 is going to be a reflection of pi over 3, and that is halfway over and up √3 over 2. Now when I reflect back this way, my x becomes negative, and when I reflect down here, my y is also negative. So now I've got -1/2 and -√3 over 2. So to do this, I need y over x. So I've got -√3 over 2 over -1/2. And this is going to simplify. The negatives are going to cancel. And I'm dividing by 2 on top and bottom. So when I multiply by the reciprocal here, I end up with simply √3. All right, let's try sine of -2 pi over 3. So I go around and let's see, I'm going 2/3 of the way to pi in the opposite direction. And wait a sec. Oh, that's the exact same place as right here. Sine is my y coordinate. So I've got -√3/2. All right, let's try cosine. 11 pi over 6. 11 pi over 6, boy, that's really close to 12 pi over 6, and 12 pi over 6 is 2 pi. So that's going to be almost all the way around. Or I can think of it as a mixed fraction, 1 and 5/6 pi. So I do 1 pi and then 5/6, and I end up right here. So there's 11 pi over 6, which is a reflection of this one, which is pi over 6. And we know that that's √3/2 over. It goes up 1/2. When I come down here, my y becomes negative, but that doesn't really matter because cosine is my x coordinate. And I get √3/2. All right, we're going to have one more set of these. At this point, you really should pause and try these before I go over them. All right, here we go. Cosine of 7 pi. Boy, we're going to go around 7 pi times. Let's think about that. So I'm going to change colors so we can see what's happening. So here we go. I've gone around 2 pi, go around again, 4 pi, go around again, 6 pi, and 7 pi lands me right here. All right, so this is at -1, 0. Cosine is my x coordinate, so I got -1. Let's go back to blue. All right, sine of 5 pi over 4. We should be thinking of it being 1 and 1/4 pi. Puts us right here. Remember over here, we reflect over and down. This was √2/2, √2/2. They're both going to be negative over here in the third quadrant. -√2/2, -√2/2, and sine is our y coordinate. All right, and our last one in this set is the tangent of 2 pi over 3. So if 2/3 of the way to pi, so 2/3 of the way to pi is right here. This reflects back to this one, which is 1/2 √3/2. So when we come back over here, we're at -1/2 √3/2. And we're going to divide y over x. So √3/2 over -1/2. And this simplifies to -√3. All right, so we're done working